Hello students, welcome to my YouTube channel. Today I'm gonna help students of class 9 and 10 with their optional math, which is also called trigonometry. Anything we learn, if we understand the fundamentals of the subject, then it would be easy to understand the subject very well. So in this beginning lesson, I would like to help you understand what trigonometry is. It's a basic foundation, what it is all about. I'm gonna tell you about that. So basically, trigonometry is this word is formed with three different parts. One is tree, other is gone, metry, three parts. Tri means three, gone means side, and metry means the measurement. So it is basically the uh, study about a measurement of right-angled triangle, which has three gonos. Gonos, that means sides. Uh, and trigonometry is about the measurement of the sides. So this is the basic concept of trigonometry. Let's draw a right-angled triangle. We should understand in trigonometry, we study about the right-angled triangle, not other angled triangles. Only the right-angled triangles in trigonometry. So let's write ABC, and suppose ABC is a right-angled triangle. ABC being its vertices. As I said, trigonometry is the study of measurement of sides of a right angled triangle. It's the basic thing. If we understand these things, then it will be very helpful to understand and go on learning and being able to find solutions on the subject of various expressions, trigonometrical expressions like finding values, etc. Uh, so as I said, this is the study of measurement of sides. ABC is a right angled triangle. Uh, Here we have parts of a triangle. They are AB, BC, and AC. Angle ABC is a right angled triangle which is 90 degree. And there are other angles, whichever it may be, they may be, but one angle is right angle. It's the it's all about trigonometry. Other angles can be any. Suppose this is theta, this is alpha. So here three angles, one being 90 degree and others being others, depending on situations. It can vary, they can vary. And there are three sides AB, side BC, and side AC. Here, of the other angles, one is called, can be taken as a reference, angle of reference, means with respect to which we call or give these sides the names. Like if this is the angle of reference, theta is the angle of reference, then AB is perpendicular, perpendicular, then with reference to this, with respect to this being the angle of reference, this BC on which angle 90 degree right angle and this angle of reference is based is called base, which is denoted by B. And there is another which is opposite to angle 90 right angle of the right angle triangle. This is called hypotenuse, denoted by H, and this is hypotenuse. This is slant. This hypotenuse is always slant. Perpendicular and base are perpendicular to each other. However, we call this side opposite to reference angle of reference, which is theta in this case. In our case, because we have assumed this as the angle of reference, this side opposite to angle of reference is called perpendicular, and this is base on which right angle and angle of reference is based. As I said earlier, trigonometry is measurement of sides, measurement of angles of right angle triangle. So it's very simple. It's not a big issue. It's not a big thing. With this basic in knowledge and rising from this fundamental, we can understand and solve expressions, other expressions of optional expressions. Here, one thing is very interesting in the subject of trigonometry, and that is ratio of the sides, any two sides of the right angle triangle for a given reference angle of reference, it remains constant always. This is the very interesting thing about trigonometry or right angled triangle. The ratio of one side to the other is always same, remains same for any given angle of reference. Uh, Here, angle ratio of P to B, say it is X for this angle of reference theta. Then this ratio P to B is always X, means same, doesn't change if even if these sides are elongated. Sides are elongated. But keeping this angle of reference constant, that is theta. This is the property, this is the fundamental thing about the right angle triangle, that the ratio between any two sides of the triangle is same. It never changes if this is constant. Now we have elongated these two, B1, B dash, or say B1, and here this to A1. Now, with elongation of this base and this hypotenuse, or let's say only one, this side base, then automatically to complete the figure of right angle triangle, we have to extend it to proper length. And all the three sides becomes large. So that here P also has been longer, base also has been longer, hypotenuse has also been longer. So in this, what we find is, or what is the fundamental of trigonometry is that the sides gets longer in the ratio that it remains constant. So here P1 by B1 is also X. So ratio of any two sides of a right angle triangle is constant for a given angle of reference. If we do further, elongate it to B2 and this to A2, then A2, B2, that is P in this uh, P2 in this new case, that P2 by B2 will also be the same. So this is very amazing or wonderful thing about trigonometry. And based on these things, all the numericals based on optional math or trigonometry, uh, it depends on all these things, and all other expressions, formulae, etc. are derived on this basis. They arises from this basic. So if you understand this thing, it's very helpful to understand the subject uh, very well. Uh, Now, to make it further clear, let's draw another triangle uh, here. Side angle is larger than this one, as it is obvious from the figure, and this is, say, this cannot be theta because angle is different, so it is denoted by another symbol, and again let's name them as ABC, vertex of the right angle triangle. So as this, for a given reference angle of reference, ratio of one side to other remaining same is the fundamental of the trigonometry. So that applies here as well. But ratio is different uh, for alpha than for theta. Suppose here it is x, here it will be another. But for the same angle alpha, though these sides are elongated, that you know that ratio will remain same. That will not change. For example, suppose here it is P H B. Here ratio of P to B equals to, let's say, Y, because it's theta here in this case, angle of reference is theta, here angle of reference is alpha. They vary from each other, they differ from each other, so ratio is different. But for the same angle of reference, uh, this ratio will always be same again, as in this case. So P1 by P2, B2, B1 is again Y, because uh, angle of reference alpha is been kept. If we suppose that is been kept, only sides been elongated as in this case, like here. And further, if new perpendicular is obtained, then even then P2 and B2 gets elongated, keeping the ratio between them the same as before. So it is. So what we understand from this is any ratio of any two sides of a right angle triangle for a given angle of reference, it is ratio is always same. Ratio of side to the other. So this is the basic thing about trigonometry. Uh, so we have understood that trigonometry is the measurement of sides and ratio of the sides with respect to each other. The ratio of one side to the other. This is the basic fundamental matter, fundamental thing about the trigonometry. And another thing we have to learn is the ratios are named. Ratio of one side to the other is named. For example, P by B perpendicular to base is called tangent. Tangent of tangent for angle theta. Angle theta. So ratio of P to B perpendicular to base is called tangent of angle theta. This is to be noted. And ratio of B to P is called cotangent of for angle theta. For theta. Similarly, P perpendicular to hypotenuse is sine for angle theta. Similarly, H by P or ratio of hypotenuse to perpendicular is cosine for theta. Likewise, B by H, B by H is cosine for theta. Here, H by P cosec for theta. B by H is cosine of for theta, and hypotenuse to B is termed secant for theta. So uh, it's clear ratios are named. There are 6 ratios for 3 sides. six ratios of two sides, one side to the other. And here, at this time, it would be uh, good. It will be good to mention that this BP or cotangent is reciprocal of tangent, because you know their ratio is inversed. Sides are inversed in these two. P by B, whereas here B by P. So uh, here cotangent is reciprocal of tangent, and conversely tangent is reciprocal of cotangent. Reciprocal means, for example, uh, A equal to 1 by B. So suppose A equals to 1 by B, then we say A is reciprocal of B. Uh, Similarly, tan tan theta equal to P by B, cot theta equals to 1 by tan. Tan theta, this is reciprocal, as I said. As I said, cotangent is reciprocal of tan. It means cot theta equals to 1 by tan equals to, we know tan theta is P by B, P by B. Then when it is inversed, reciprocal, will become, the expression will become B by P. That's why cot theta equals to B by P, which is cotangent is B by P. That's why cotangent is reciprocal of tan and tangent is reciprocal of cot. Similarly, here sine is reciprocal of cosec, and cosec is reciprocal of sine, and cosine is reciprocal of secant or sec. Secant is reciprocal of cosine. So here we learned that uh, the sides, ratio of the sides, and their name. How they are named, what are their name, what they are called. So these are the, we have just learned. So I hope you have understood up to this. Uh, Now moving on, you I erase, wipe out this. Now we shorten whatever we have written, uh, the name of the ratios. We shorten the name. For example, P by B equals to, we understood that P by B is tangent for angle theta. Here, instead of writing tangent for angle theta, we write tan theta. So, tan theta is written as P by B, or tan theta is the ratio of P to B of a right angle triangle. Here, theta is angle of reference, P is perpendicular, and B is base. So, we go on writing what we previously mentioned, and the ratios and their name, we now write them down shortened. Cot theta, cotangent is now abbreviated, or it is shortened to cot. Cot theta is B by B, because this is the reciprocal of tan theta. Sin theta perpendicular to H. SINE, sine for angle theta, is now shortened to sin theta, and it is written as sin theta equals to P by H. P by H is the ratio that is named sin theta. Cosec, its reciprocal is cosec theta equal to H by P. And we have cos theta. Cosine is shortened to cos. Cos theta is B by H. And secant, or shortened as sec, is the reciprocal of cos theta, and it's the ratio of hypotenuse to base. So this is the basic thing about the side of a right angle triangle, and basic about the ratios of the sides, any of the two sides of the right angle triangle. And whole trigonometry is based on this and nothing else. This is the foundation, and everything does evolve from this. So it's important to understand. For example, later on, many of you know also that sine square theta plus cos square theta equals to 1. Later on, we'll learn about this expression. But what I'm gonna do here, gonna tell you, means, everything about the which we learn later on is about the ratio, this ratio. And however, it looks like a big thing, but it's nothing. If you understand this basic thing, you will understand all. All the things that follow later on, expressions with name of the ratio like sine, cos, tangent, cot, sec, cosec, etc., whatsoever, they all are the ratio. They are all about the ratio. I'm gonna show you this. For example, later on we understand, learn that sine square theta plus cos square theta equals to 1. This, so how it is related to ratio. For example, I said sine theta is P by H. P by H. So this is square, means this square, H square, plus cos is B by H, B square by H square equals to equals to, here we do simplify this, it becomes p square plus b square upon h square. So according to Pythagoras theorem, p square plus b square is h square. So I will explain it later on that about the Pythagoras theorem. Simply here, I refer to the Pythagoras theorem saying that p square plus b square is equal to h square. So here it becomes h square by h square equals to h square by h square. So both cancelled is 1. So what we see is this is all about the ratio of the sides. Ratio of the sides of uh, two sides, any two sides of the three sides of the right angle triangle. So I mean to say this means uh, this is all about the ratio and nothing else. Students, this was for today. I'll be coming up with a new lesson to help you with the optional math, trigonometry in coming days. Thank you very much for watching.